Okay, Advent code day 13 in Bash. Let's go. Day 13, point of incidence. With your help, the Hot Springs team locates an appropriate spring which launches you neatly and precisely up to the edge of Lava Island. There's just one problem. You don't see any lava. You do see a lot of ash and igneous rock. There are even what looks like gray mountains scattered around. After a while, you make your way to a nearby cluster of mountains, only to discover that the valley between them is completely full of large mirrors. Most of the mirrors seem to be aligned in a consistent way. Perhaps you should head in that direction? As you move through the Valley of Mirrors, you find that several of them have fallen from the large metal frames keeping them in place. The mirrors are extremely flat and shiny. Many of the fallen mirrors have lodged into the ash at strange angles. Because the terrain is all one color, it's hard to tell where it's safe to walk or where you're about to run into a mirror. You note down the patterns of ash and rocks that you see as you walk. Perhaps by carefully analyzing these patterns, you can figure out where the mirrors are. To find the reflection in each pattern, you need to find a perfect reflection across either a horizontal line between two rows or across a vertical line between two columns. Add up the number of columns to the left of each vertical line of the reflection. To that, also add 100 multiplied by the number of rows. I have an idea. I have a couple of ideas. How big's our input? Probably pretty big. Oh no, it's a bunch of little ones. So I'm thinking what we do is we walk a line, one line at a time. We find all of the places that are reflections in that line, and then we're gonna do that for each row. And if it happens in the same index on every row, okay. I have a plan. Kind of. It's not a good plan. While ifs equals read a line. Okay. If line is a new line, then what do we do? Let's do one puzzle at a time. Lines equals lines line. We lost our new line. Why is that happening? Oh, because it's printing it out every time. This is so dumb. Jeez. Okay, we got there. Now we need to call solve with lines. We do that whenever we hit this. Okay. But we can solve the multiple now. Let's pop an exit 0 down here so we can just focus on 1. So for each line, we need to find the reflections. So if I'm walking the string, I know my index. Let's do 1 line. Okay, we're reading the characters. We want to go from 1 because we're counting the gaps. So maybe instead of doing this read loop, what we should do is len equals that, and we can do a for loop for I equals 0, local I, to len minus 2. And we say we want to get the left and the right side of our string. Left, right. So we're gonna go left equals, it goes from 0 to I plus 1. Yeah. And the right starts at I plus 1 and goes to the end of the string. Yeah. Okay. So now the thing that's interesting is that we need to clamp the string. So the right one, whichever one's longer, we take that length. If right is greater than left, then we say right equals right 0 trim. Okay, so that trims it that way. But when we want to trim the left one, we have to trim off the beginning of it. Oh, that's easy. So if left is greater than right, we are gonna trim it to trim. Don't judge me. All right. I don't go into your code base and judge you unless you ask me to. We want the difference between the two. Let's call this like R trim and L trim. So the left goes from trim onwards. Is it the other way? Yeah, that's what I meant. Okay. So now we just need to do some string compares. If left is equal to the right, then echo I. 0 can't be 0. Oh, it's not whether or not they're equal. It's whether or not they're mirrors of each other. We need to reverse one of them. All right, we're going to rev it up. Left equals echo left rev. Okay, now I think we should be getting better answers. Yeah, 5 is consistent across the board. Great. So you might be wondering, what are we going to do with all of these numbers? Well, we're going to count them. Listen, I know you're skeptical right now. What we're going to do is we're going to find the one that equals the number of lines that we have. Grep 1 space. This is going to give us any lines that are the horizontal mirror. And then what we're going to do is steal AOC 2023 day 11. Oh, transpose might not be exactly a rotation. Is that what it's supposed to look like? Yes, we should have a line of symmetry down here, right? Because if we go 3 this way, interesting. It looks symmetric to me. So I think the transpose is working. Although, you know, now that I'm looking at it, this isn't going to give us 4, is it? So what is my algorithm not accounting for here? Okay. I see what's going on here. Yes. No, count is not this. Count is, what is count? Okay, instead of count, this is height. Lines equals line, width equals line. That's what I'm missing. So this needs to be using width. There we go, 400. Let's get our input. Okay, it's cooking. Let it cook. Look at it go. It is slow. It's slow, but it's, you know, it's going. Here we go. Easy. Literally easy. Okay. Why are you saying part 2 is going to be fun? You resume walking through the Valley of Mirrors and smack, run directly into one. Hopefully nobody was watching because that must have been pretty embarrassing. Upon closer inspection, you discover that every mirror has exactly one smudge. Ah. Oh no. Exactly one Asher rock that should be the opposite type. In each pattern, you'll need to locate and fix the smudge that causes a different reflection line to be valid. No, I actually have a thought process for this. Don't worry. It's already cooking. It's not going to be fast. It's okay. It's okay. I'm surprised there's only one case. Is that true that there's only one case where the smudge changes things? Is that reliable? It must be, because how else would the puzzle work? What I was thinking is that we could, because right now what we're doing is we're printing out every index that is reflected per row. What we could do is also print out ones that it could be. We could be like, this one is only one character away from being a match. And then we have to do some like correlating with that. Wait, am I a galaxy brain? So instead of grepping for the count, we can grep for the one that's one away from the count, one below the count. And that should find us our like almost solved line if there is one. Yeah. Okay. 400. Now we wait. I'm also not 100% that this is correct, but I'm like 40%. Get there. I'm 100% confident that it's correct. We've done it again.